Hey everyone, and welcome. Today, we're tackling Leetcode problem 2169, count operations to obtain 0. This is a great problem that starts with a simple idea, but has a really neat, efficient solution. Let's break it down together. Alright, let's look at what the problem is asking. We're given two non-negative numbers, let's call them num1 and num2. Our job is to keep subtracting the smaller one from the larger one until one of them becomes 0. And all we need to do is count how many subtractions it took. So to put it simply, we're in a loop. We perform an operation over and over again. The loop stops the moment one of our numbers hits 0. The final answer is just the total count of how many times we ran that operation. The rule for each operation is straightforward. You just look at the two numbers. If num1 is the bigger one, or if they're equal, you subtract num2 from it. If num2 is bigger, you do the opposite. It's always the larger number minus the smaller number. Let's walk through an example. Say num1 is 2, and num2 is 3. 3 is bigger, so we do 3 minus 2, which is 1. Our numbers are now 2 and 1. That's one operation. Now 2 is bigger, so we do 2 minus 1, which is 1. Our numbers are now 1 and 1. That's our second operation. Finally, they're equal. So we do 1 minus 1, which is 0. Our numbers are now 0 and 1. And since one of them is 0, we stop. The total count was 3. So the most direct idea is to just write a loop that does exactly what the problem says. While neither number is 0, we perform the subtraction and add 1 to our counter. This is perfectly correct, but it can be really slow. Imagine if num1 was 1,000,000 and num2 was just 1. Our loop would have to run 1,000,000 times. That's not very efficient. We need a shortcut, and that shortcut comes from a classic algorithm called the Euclidean algorithm. The key insight is that performing the same subtraction over and over is really just another way of describing division. For example, if you want to subtract 3 from 10 as many times as you can, that's the same as asking, what is 10 divided by 3? The whole number part of the answer tells you how many subtractions you can do, and the remainder is what's left over. This lets us perform potentially thousands of steps in a single calculation. Okay, we've got the core idea. Use division to speed up the subtraction. Now let's see how this translates into actual Python code. I'll put the full solution up first, and then we'll break down the important parts line by line. Alright, here's the code from the editorial. It's pretty short and clean, right? It's just a simple loop that uses our division trick. Let's zoom in on each piece to make sure it's crystal clear what's happening. First, the while loop condition. In Python, a number is truthy if it's not 0. So this line just means keep looping as long as both num1 and num2 are not 0. Next, this if statement is a nice cleanup step. It just makes sure that num1 is always the larger of the two numbers by swapping them if needed. This makes the next part simpler. Here's the core of the optimization. Instead of subtracting one at a time, we use integer division to find out how many times the smaller number, num2, can be subtracted from the larger num1. We add this number directly to our result. And finally, after we've done all those subtractions in one go, what's left of num1? It's just the remainder. So we use the modulo operator to update num1 to be that remainder, and the loop is ready for its next, much faster iteration. So how much faster is this? The time complexity is big O of log of the maximum of num1 and num2. That's a bit of a mouthful, but it basically means the solution is extremely fast. Because we're using division, the numbers shrink incredibly quickly. Much like in a binary search, the number of steps depends on the number of digits, not the actual size of the number. And for space, we're just using a few variables to store our numbers and the result. So the space complexity is big O of 1, or constant space. It's super efficient. Alright, that covers the main solution in Python. As promised, for those of you who code in other languages, I'm about to show the full solutions for Java, C++, and JavaScript. I won't be breaking these down, so just pause the video on your language of choice to check it out. Alright, as promised, here is the full solution in Java. You can pause the video here to take a closer look at the implementation. Next up, here is the C++ version of the solution. Again, feel free to pause and review the code. And finally, here is the solution in JavaScript. Hopefully seeing it in a few different languages helps solidify the concepts. So let's quickly recap the main points. The first, most obvious approach of just simulating the subtractions works, but it can hit a time limit if the numbers are far apart. The key takeaway is realizing that a long chain of subtractions can be replaced by a single division and a modulo operation. This insight, which is the core of the Euclidean algorithm, gives us a super fast and efficient solution. Alright, before we wrap up, I want to quickly show you a personal project I built to solve a problem that always drove me crazy. It's an app called My Daily To-Do. My biggest frustration with every other to-do app was retyping the same things every single day. Go to the gym, review code, work on the daily Leetcode problem. You know the drill. So I built my app around one simple but powerful idea: separating your routine tasks from your one-off tasks. Routine tasks, marked with a little refresh icon, automatically reset for the next day. One-off tasks, like ship new feature, get the little puff of smoke icon, and they disappear for good once you're done. This small change turns a dumb checklist into a smart scheduler. If that sounds useful, you can try it right now on the web. The link is in the description. And one more thing I want to make super clear. Right now, as a thank you for being an early supporter, the app is 100% free. There are no ads and no subscriptions whatsoever. This means you get access to everything, including really powerful features like presets, which let you save entire task lists and load them with a single tap. Now, down the road, creating new presets will likely become part of a premium plan to help support the channel. But, and this is the important part, any presets you create now, while it's all free, are yours to keep and use forever. So it's the perfect time to check it out on the web, play with all the features, and build out your perfect setup at no cost. If you enjoyed this problem and want to keep practicing, the learning doesn't have to stop here. I've organized all my video solutions into handy playlists. Whether you're looking to grind through more Leetcode easy, medium, or hard problems, or you want to master a specific topic like sliding window or dynamic programming, I've got a playlist for you. It's the perfect way to focus your study sessions. Go to the playlist tab and find a playlist that fits your goals. Hope this Leetcode solution breakdown made sense. If it helped, give that like button a click, maybe subscribe for more, or drop a comment if you have questions. Make sure to turn on the notification bell so you know straight away when I upload a video, because I upload videos daily. If you want to support the channel, a few people have asked how I plan my solutions. I'm a big fan of sketching out the logic and data structures on a tablet before I code. It really helps. I've put affiliate links in the description to the tablet I use and a few other good options. Using those links doesn't cost you anything extra but really helps me out. Or, if you're feeling generous, there's always the Boba Fund. Keep coding, and I'll catch you in the next one.